One of our major competitors, and now the only one left in the northeast, they still use a lot of steam. Of course, there's Peterhead Power Station. All their turbines are steam driven. That's probably the biggest. All the distilleries, of course, around this area will all use a lot of steam for their process as well. There's a lot of requirement for steam engineers.
So it's near a dying trade, really?
Definitely not.
George, you're manager of the factory here. Could you tell us about, for instance, your suppliers and also the distribution of the product after it's been processed?
Yeah, sure. The raw material comes from a variety of local fish processors, all the way from Peterhead right around the coast through Lossiemouth, Buckie, right through as far as Inverness. You also get considerable amounts withdrawn from the fish market for various reasons. It could be that it's been in the fishing boat too long, or it might be the wrong size, and that's withdrawn, so we get most of that. And then from other fish processors up and down the length and breadth of Britain, coming from as far as Ireland and Cumbria, Hull, and this all comes in by big bulk lorries. And then of course there's the industrial fishing, which is the definition of industrial fishing is anything that's not fashionable for the human consumption market. This is the likes of blue whiting, argentines, buck mackerel, capelin and sand eels. We make two main products, fish meal and fish oil. Both are dispatched all over Britain. Fish meal is used for mostly animal feeds, and we have a considerable number of distributors to deal with the farmers and Grampian country feeds, for instance, and animal feed. But one of the big customers these days is BP Nutrition, who make fish feed for the fish farming, the aquaculture. They use both the fish meal and fish oil and make pelletized feed. They've got a big plant along at Invergordon and make mostly salmon feed along there. And about 70% salmon feed and 30% trout feed. They have another plant down in the south of England where it's something like 70% trout feed and 30% salmon feed. The meal itself is from two types. Our intake is pelagic fish and whitefish, and these divide into two distinct types of meal. One is a herring meal, of which it's a 70% protein value, and a whitefish meal, which produces a 65% protein value. The herring type meal, pelagic, that produces considerable oil, whereas the whitefish, very little oil. Both of these products go out in two forms, in bulk lorries or in bags. The distributors that sell to the farmers and that, usually like northeast farmers and people like that, they usually take it off in bags. And the larger concerns like Grampian Country Feeds, they take it off directly in bulk. Fish oil itself goes for a whole variety of products, something like 200 value-added products, from cosmetics and pharmaceutical preparations to leather treatment such as Dublin and things like that. But a big user of the fish oil is in the manufacture of margarine. This factory itself has been around some 60 odd years, and whoever put it here in the first place knew very well what they were doing. We were about a mile outside of Fraserburgh, to the west of Fraserburgh, and the prevailing winds over the whole year have more or less, something in the region of 80% have a southerly element in it. From that point of view, if any of the smell that's created, it goes over the sea. For a small part of the time, there's a northeasterly, when you get the cold northeasterly wind in winter, and that coincides with the pelagic season, when you get that in fact produces a bit more smell than the whitefish, and it deteriorates quicker. Now over that time, the smell would have gone over to the west of Fraserburgh, over the farmland, which was not very well populated. There was only a very small part of the time when the wind would be over from the northwest and thereby over the town. Can we leave this down a minute and now? That's fine then, George. Okay then, yeah. That's George Ellis from... I thought so.
And it's got it's hollow, it's steam in the jacket, and the rotor itself is hollow, and steam goes up the middle of that as well. It takes about 20 minutes to go from this end to the far end. Drops onto a screen conveyor there, where the liquid, as you know, fish is about 80% liquid. Depending on whether it's pelagic or whether it's whitefish, it can be as much as 30% oil or 1 or 2% oil. That oil, that liquid is taken off and goes to tanks over in the far corner there. The solid matter drops onto the press, and then it goes up, comes across and goes through the dryers. More liquid is taken off in the press, that goes over to the tanks, and then you decant it, you get some more of the solids out, it goes up to another tank, it becomes stick water then, which you then put through the separators, and you separate the oil from the water. The water then goes through the three-stage evaporator, where you boil it up under a vacuum, and it thickens it up. That in the old days used to be fish glue. We used to make fish glue. Nowadays, we reintroduce that solubles into the meal. That increases the yield by 3% or so, and also increases the protein, which is a more important factor. Just have a walk up here then. Again, with the barrel increases in size, the plates themselves stay the same size, and but the volume at the inlet is, by being pushed along, is thereby decreased, and so that's how you get the pressing action. Up to the tank, and then goes to the far unit, which is set up as a purifier, and it just polishes the oil. Comes out a nice golden crystal appearance to it. And then the liquid that comes off it goes over to the evaporator. Quite noisy in this pot. Compression of the vapour is what produces the heat, and then and you get the boiling action. For the higher capacity, it's much more efficient energy-wise. Use more electricity, but the cost of the electricity is cheaper than the steam heating. Largely depends on the capacity. Cats around, you know the way cats like fish, but so do rats and other animals. So we keep about 3 cats on site, mainly for this purpose, simply to keep down the undesirables. He's not a very nice looking cat, but he is one of the workers. He's obviously on night shift. With about 10, with 10 small tanks holding about 40 tonnes apiece, and then the 2 large tanks over there, they hold 400 tonnes. Then we transfer it to the one big tank over there, which holds 50 tonnes. That holds about 2 loads for the road tankers that come in. It all goes out by road tanker to all over the country. 7 Seas Marfleet, they're customers of ours. Put it in here, and that and the one that's on the front, which has been totally refurbished. Oh, now George, you're asking a question there. Because it's a smaller unit, it would probably be cheaper. But having said that, if you had 500 tonne a day to process, you'd be better off with 2 plants like ours rather than 10 small plants.
Percent concentration. This, in the old days, was what used to be made, or which was what carpenters and joiners used for fish glue. But as time went on, this was very expensive. It was a waste of a good material. So we started getting all the more modern glues that you get now anyway. So this concentrate, or solubles as we call it, is introduced into the dryer with the press cake. This increases the protein value by as much as 3%, and indeed the yield. So it was always very desirable to get as much back as we could.
So there are still factories working the same principle as this factory?
Oh yes, very much so. With more modern equipment.
Mm-hmm.
But the basic idea, the cookers, the presses, the centrifuges, the evaporator, all these basic elements are still there, and apart from the separators, they are driven by electric motors, but and the press is driven by an electric motor. That's a mechanical device. But the cookers, the evaporators, and the dryers, they still get their heat source from steam, because that is, again, to say, the most efficient way of heating the surfaces.
What about repairing a plant like this, George? Is it still feasible to repair a steam plant?
Very much so. We've, on the previous video that you made, when you had a look around our factory, we've a dryer on these units, on the yard, a spur dryer. They cost about £250,000 new. We had that spur dryer completely refurbished. Now it cost £110,000, but it was still worth it, and that is almost a new machine. We have all of this equipment comes under regulations regarding pressure vessels. Obviously 100 psi is quite a pressure for ordinary everyday people, so there are lots of rules and legislation regarding pressure vessels, and it is this legislation which is the main element which determines what sort of repairs are required in any of this. And it's all highly qualified people, mostly welders that are involved. If you've got thin steel shell, say this gets thin, then we actually cut it out and stick in a new plate back to the original thickness. This is engineering, and in its truest form. Any machine is made by man in the first place and can be repaired by man. It's just the economics of it usually that determines whether to buy a new one or whether to have an article repaired. Most of us these days would tend, for instance, to buy a new car or a new car engine rather than have an old one repaired. But it's perfectly possible, as we've all seen in vintage car rallies and things like that. You've got some very, very old machine. It's not that they have stood up with the test of time and lasted well. They've had a lot of attention actually paid to them. The bodywork might well have been replaced, or the chassis, parts of the chassis may well have corroded. You can take steps by painting and coating to slow down corrosion and things like this, but it does happen, and over a period of years they have to be replaced. Most of us find it more easy to go and buy a new car rather than have it repaired.
Can you still actually buy new parts though for steam plant, George? Or is it mainly older parts being refurbished and that, is it?
No, there's still all of these dryers, for instance, the dryers and the cookers are made by our particular firm. There was an associated firm years ago that was split up now. It's Stored Barts, Atlas Stored, they're all part of Stored, and they actually make these usually to order anyway, but all of these parts are actually made if a shaft goes on it or valves or whatever. All of this would be new parts, can be made and fitted.
Is there still a future for steam today, George?
There will always be a use for steam. I think as we get pollution control and the legislation affecting effluent and things like this, obviously want cleaner forms of energy. But having said that, even if we use electricity, for instance, all we're doing is centralising the bad effects of the conversion. I mean, a power station, for instance, generates steam, whether it be Dounreay, which is a nuclear power station. All that actually happens is that the fuel that's used, instead of it being coal or gas or whatever, they use radioactive isotopes or uranium or that is the fuel. And in splitting the atoms and what they do in that industry, all they do is produce heat, which is then converted into steam, and what actually produces the electricity is steam, a steam turbine, just like a coal-fired power station or a gas-fired power station. The only difference when it comes to power is that there were several power stations, small power stations up and down the country, which the driving force was by a big diesel engine. But other than that type of power station, you have some form of combustion, and you have the smoke and the effluent going out at one point. So you're still using steam, and steam as a technology is still very, very much used. In fact, some of the alternators I worked on, if I can just do a diagram here, this is the representative figure for a turbine. It goes in at this thin end, and it's supposed to represent the expansion of the steam, so it comes out at the wide end. So you'd have 100 psi steam there, and in that one pass might have 30 psi steam there. And in days gone by, that would maybe used for something else, heating or something like that. But nowadays technology, that takes it along and puts it back into the turbine, and it might go into the turbine several times and be used several times to make use of the energy in it. Or it might indeed go to another unit, another turbine, which is designed to only start at 30 psi, and that might actually be connected to it. So you start off at a narrow, this would be the narrow end here representing there, and it would go to an even bigger end. It gets bigger and bigger. It goes according to the expansion of the steam. So steam is probably used more today than it ever was, but in a different context and a different environment. Most refineries up and down the country use one heck of a lot of steam to crack the fuel, crack the oil, and get the petrol that we have for driving our cars.
So there's still a future for steam engineers today, and they're still producing steam engineers.
Still producing steam engineers, and it's a discipline which is getting more and more specialised. And the studying I had to do was it's very detailed. The formulas, by today's standards, we've got plenty of calculators and computers to do all the work. As long as you understand the formula, it becomes pretty easy. But in the old days, when we only had a slide rule, it made calculations very laborious. But there's a lot written about steam and the expansive properties of it, as well as the heat that's in it, and how you can get the work out of the steam.
So there's a lot of people who believe that steam was something in the past, so it's enlightening really to realise that there's so much steam being used today.
Well, as I say, probably what I said before about Dounreay or any modern nuclear power station, most people think that the electricity is produced by some magic process, but it isn't. The electricity is still produced by steam, and that sort of steam, you're talking about 2000 psi, and it's still 500 degrees C as a rule. That is the limit of the steels that are used. The temperature that the steam is taken to, that's called superheated steam. That acts. You've got to. I'm trying to keep it simple. It's the expansive properties of the steam at that state is more like a gas, which have a completely separate set of laws and formula for working out their properties. When you've got vapour involved, they're different. They're a different type of formula.
So do you think there's maybe still a future in the steam car? It was something that was laughed about a few years back, but maybe there's still a future in that, is there?
There might well be. In fact, if I remember rightly, on Tomorrow's World, only last year or so, there was a car which you burnt fuel in a chamber, and then you had a separate engine and a separate compartment which was fed with water. The limit was that you ran out of water before you got all that far. So they haven't. The steam was just exhausting to atmosphere. So you'd have 5 gallon or 10 gallon of water, and you wouldn't get very far before that water had all gone. The later version of that car was for it to actually have a condenser and then reclaim the water so that it just stayed in a circle and stayed in the car. And I think the day will come. It is a clean form of energy. If you can contain and have the heat produced in a small chamber and tightly controlled combustion and get the most heat out of it. I mean, an ordinary car engine, for the amount of fuel that you put into the car engine compared to the energy you get out, it's very inefficient. There's a lot of heat and energy just goes out the exhaust. Now, if that could all be harnessed, and then which they are developing, and it's in a steam car I have seen such a development.
So what qualifications has a steam engineer got to have today, George? I mean, is it a university degree? Is it something through the college that one has got to learn? Or can one learn it through practical experience and like learning a trade?
My qualifications, if I could start, I served my time as an apprentice first of all. It started off as a mechanical engineer for seagoing use. But that's, I studied OND in mechanical engineering with a marine bias. The marine bias being the awareness and the safety of electricity. So we're actually a mechanical stroke electrical engineer. That then goes on to take what we call our Department of Transport, as it's called now. In the old days, people remember the Board of Trade or the Ministry of Transport. It's been called many things. But they set the examinations and what has to be studied. The actual degree that you go to is almost degree level, HND stroke degree level of to get your first class certificate. You can then go on to study for extra first class certificate, and this is at degree level. Most engineers, most steam engineers today, they've changed the qualification structure over my period, and to do the work that I did would definitely be studied at university, or certainly a good polytechnic who specialises in engineering. It starts off with engineering. You've got to have a good understanding of engineering in its whole concept, really, the strength of materials and forces. You've got to have this knowledge as well. So you cannot really just take the study of the steam, which is actually called, the proper name for that is thermodynamics. You cannot just take that without you look at all the effects that the heat and the pressure will have on, for instance, the pressure vessels or the crankshafts that the steam is being used on, or the shafts. So the strength of materials, metallurgy, mechanical properties of it, all these things will come into it. Yes, so as I say, it embraces so many aspects of engineering, and then you specialise in the thermodynamics side of it. The thermodynamics as well, we studied what goes on inside the engine of your car, the ordinary petrol engine, and in fact another form, a gas turbine, which is you don't hear very much of gas turbines. The Royal Navy did a lot of research and used that principle where they're just able to burn gas. It produced gas in a chamber and then that drove a turbine. But they all follow very similar laws, and they're long and complicated. When you've got polytropic expansions, isothermal expansions, all fancy names for them. I remember them. I cannot remember them now, but we had to remember them for our examinations. Nowadays you can just be given a formula and work it out in a computer. But the basic principles of how these formula are derived at, that is a tremendous insight into understanding how, whether it be steam or gas, how it behaves in its expansion when it's burnt or when it's used in a machine. It's no use building a machine, let's say, which would maybe have an input of 1,000 psi, and it's just going to blow up like a balloon. That's why all the other engineering aspects have to be taken into. It is a vast subject, and these days, because we haven't got many ships, which was in the past a tremendous source for the steam engineer, nowadays it would all be done at colleges and universities, and it would certainly be from that level that the recruitment would be today.
Would a steam engineer of the past be completely confused by steam engineering today, George?
The very early engineers would be, going back 60, 70, 80 years ago. Yes, they really only studied the safety aspect, how to make sure that they didn't get burnt, how it didn't explode on them. They didn't go study the actual laws of how the steam expanded, the pattern, and they just knew it happened, like so many aspects of engineering. But the standard to which, when I was an apprentice, the standard of study that we did, I would say that today's engineers, steam engineers, would just study the same as we did. It's just that it would be a different place of studying and a different place in which to get the experience. So I'm thinking mostly now in terms of the sort of steam that you would use at a power station. They are the biggest users for the true steam engineer. We make use of steam, as I say, on this factory. We do not need, when it comes to running the factory, we do not need to know the standard of steam that I've got. It is a bonus, which when you're coming to design the plant, the size of pipelines and the size, the surface area that you'd have in the dryers, that is when it comes to, you need the standard of education and knowledge that I've studied.
So is steam engineering safer today than it was in the earlier days, George?
It's probably actually, it is in that today we calculate everything. The thickness of a pipe, for instance, and the tensile strength of that pipe to contain the steam, that is all worked out, and that is far more, we know about these things. Whereas in the old days, they used to, by sheer experience, they would always make it a damn sight thicker than it needed to be. So from that point of view, it could be said that the older type of utilisation of steam was safer, whereas we take things to the limit a lot more. But having said that, they're a lot more calculated in the first place, and with greater quality control on the likes of pipes and machinery that's using the steam, we know in advance what that machine's capability is.
So the knowledge has improved quite a lot.
Oh yes, the understanding of, and the experience.
One last thing, and you can just round it off with this, is far as the next nearest steam plant?
Aberdeen,
Aberdeen.
we're one of our major competitors, and now the only one left in the northeast. They still use a lot of steam. Of course, there's Peterhead Power Station. All their turbines are steam driven. That's probably the biggest. All the distilleries, of course, around this area will all use a lot of steam for their process as well. There's a lot of requirement for steam engineers.
So it's near a dying trade, really?
Definitely not.